Now we're going to move on to our next headliner, who is José Pedro Almeida, who's a healthcare innovator. Now, José envisaged and implemented a big data platform that is by far the most advanced in Europe and makes it one of the most advanced solutions in the world regarding the practice of data-driven medicine inside hospitals. So he's going to tell us more about it. Please give him a very warm welcome. José to the stage. Thank you.
Thank you for the kind introduction, Babita. I'm here to tell you about a story. It's a story of my personal experience for the last 5 to 10 years inside the public hospital center in Portugal. And this public hospital center a few years ago didn't even know how many employees it had. And today, as we speak, a doctor can be walking through the second floor and receive a text message from our data robot saying to him that his patient in the 9th floor is with his heart rate going up more than 20% in the last 24 hours. His blood pressure is going down 15% in the last 6 hours, and just came out a result from the lab telling that his potassium level is above 5. And so probably he would go to the outpatient area, but when he sees this message, he goes back and goes to the 9th floor to see that patient. This is working fully automated for 1,000 beds as we speak. Now, in case you are wondering the size and complexity of doing something like this in a hospital, look at the numbers of this specific scenario where we have built this. We are talking about a monster. It has 9 floors, more than 5,000 employees, 30,000 patients coming in and out every day, 30 or 40 different IT systems to integrate. So it's not about just people, it's also about technology. But it is also one of the most dangerous places you can be on Earth. This is a place where 1 in every 25 patients can get an hospital-acquired infection. I know that for some of you, this number might seem a very not significant number, but just think that once in a lifetime, you will be inside the hospital. And if you are inside the hospital, those days that you are there, you are with a high risk of getting something like this. And we should do something about this. So one of the things that struck me the most was looking at all the data that we had there, looking at my team and the talented people I had with me that knew a lot of tools and work with data, and everything was still being done as it was 20 years ago. Doctors and nurses still using the same practices. They still have problems of miscommunication among teams. Late nights and weekends are periods of higher risk. And everything went like the day before. And we tried to change this. But the first thing we did to change this was capture the data to a single place. We don't care if the data is coming from the lab, if the data is coming from a sensor, if the data is coming from text. We need to grab it, we need to build it, we need to correlate it. And have something like this that is able to show you more than 500 billion data points of data from the patients of this hospital. Now, what you are seeing there is not enough. It's just hype. Until now, we have big data, fancy slide. This is just hype. It will not be hype if you transform this data into actionable data. And to transform this data into actionable data, you need to deliver the data to the guy that is over there. Those guys over there are doctors and nurses inside hospitals. You can have all the monitoring in the world, but if things fail in the ground, everything goes down. So you need to understand what that guy needs, because if he puts the wrong fuel in your airplane goes down. And when we try to do conversations with clinicians, we need to move outside of the basement, of the IT basement, and really understand the most fundamental issues. And when we get there, some things start to appear. I don't know if everybody here knows that there is an opportunity for what we call failure to rescue cases. Those cases that somehow are in the inpatient area, they have a sudden clinical deterioration, but that clinical deterioration was already there in the data. The data would already show that that could happen. So one of the things that our team did first was build a series of AI models mixed with expert rules from the field. This is very important. And try to build a model that could predict if a patient is going to have a clinical deterioration event inside the hospital. But besides that, we try to do this for every patient, every hour inside the hospital, for all our beds, and show a priority list to our clinicians where they can say, oh, this patient, based on the data, is probably getting worse. This is stable. This patient is with consecutive fever for more than 3 days. This patient is with bradycardia. This patient is with hypokalemia. This needs to be done in a flash of a second, and this is not done with this speed in any hospital or in most hospitals. It is still a manual process. It takes time, and time saves lives. And when you try to implement something like this, you really need to think, how am I going to deliver this to the teams? Because, okay, you have that fancy dashboard, maybe they will look in their laptops, but they are rushed moving inside the hospital. And probably you need to know, where are you going to send that message? What you are seeing over there is an old Nokia phone. And everybody here has smartphones. Why do we send that message over there? Because that cell phone has cell coverage anywhere inside the hospital, and the battery lasts for 2 weeks. So this is the phone they use every day. They like it. And so if they like it, this is the place where we need to send that message. And when they start to understand what data can do for them, they bring you other problems. So another problem we were faced with was trying to reduce hospital-acquired infections, specifically those caused by multi-drug resistant bacteria. And simple stuff can be done in an intelligent way, so they can act upon it. Things like signaling methicillin-resistant Staphylo aureus in your floor plant, and showing where are the cases, if cases that get this infection are near each other. Because probably if they are near each other, you need to clean more those areas. You need to speak with those clinical teams. You need to act. But first you need to know that there is a problem there. If you look at an Excel table, you will probably not find this, because you will not see the distance between all those rooms. But then there are other problems you can attack. One of them is trying to induce a better prescription of an antibiotic with data. How do we do this? Well, most of the doctors, they prescribe antibiotics based on their past experience. But inside the hospital, bacteria behave in different ways. If they are in the 9th floor or in the 1st floor, if that bacteria lives in the ICU or outside the ICU, all these are probabilities. Our computer calculates 5 million probabilities per minute of all our bacteria, and it tells the doctor in just one click, it clicks and it tells, oh, for this infection, in this floor, for this patient, probably, based on the statistical information we have, probably this antibiotic will work best. Now you choose. So what we are talking about is trying to open a new era of data-driven medicine that we like to call computational care. And we are trying to do a transition from a rule-based models to something that is unsupervised. This is obviously dangerous. This needs to be taken with cautious, but this is an opportunity too. Because, as you know, most of the treatments still use traditional models based on linear rules. And we are in an era where machines start to learn by themselves. Tech companies have figured out ways of identifying those cars, and those cars are cars that the computer has never seen. Now imagine that we could do this with patients. Why not? Why not to try this? Why not to go back into the same problem, use that same technology you saw over there, and apply it to the same problem? And what you are going to see here is an evolution of a specific patient. On one side, you are going to see, on the left upper side, you are going to see the level of risk that our deep network is signaling for these patients. And on the right side, you are going to see what happens the next 7 days. This is important because this is signaling this patient every day, looking at all these signs. Nobody taught this network how it should work. On the 8th inpatient day, some problems appear, the risk goes up. On the 9th, it goes down. On the 10th, the heart rate is rising, so the network is signaling there. And on the 12th day, you are going to start to see that the patient is going to deteriorate. Why? Because his C-reactive protein is starting to go up. And when it is starting to go up, the level of risk of this network just pops way up. And the patient, doctors are still trying to treat him. We are going to move forward a few days. Patient had some breathing problems. It went okay again. But moving a bit forward, you are going to see, before a specific adverse event happens, how the network can signal this patient with risk up to 7 days before he dies. Signaling his potassium level going up, his heart rate going up, blood pressure going down. The patient will die in the next 7 days, but we have an opportunity to act here. Now, all this that you have seen has a lot of technology behind. To do this, we had to test 26,000 models per day to find the right model for that specific problem. This is possible because, fortunately, I have some brilliant guys working with me that are able to do something like this. I'm not going to talk about the science behind this because I know that in the audience there are a lot of folks that are brilliant in terms of the science behind this stuff. What I would like to talk is about how to make this. How do you put 26,000 models being trained every day for your specific problem? Because my team tackling this problem has only 3 guys. So it's impossible if you have the typical data scientist workflow. So to do this, you need to look at the best examples. And the best examples come from great companies like Amazon. You need to build a culture where you fail fast and learn very quickly. You need to build the infrastructure to do this. Another company doing this, taking risks, doing experiments every day, Netflix. Of course, you need to prepare the right infrastructure. You need to have hardware to do this. So this is an example of the infrastructure we have built. We have a data lake. We have traditional big data warehouse. And obviously, we have massive parallel processing to accomplish this. But then you need to help the data scientists. You need to look at the work that they are doing and try to build something that can help them do their work much faster. Because they would like to train a lot of different models. One day, they would like to train a model for people with more than 45 years old. Another day, they would like to test if this model works best from the 13 patient day onwards. Another day, they would like to test if this model works best for females. But this takes time. We need to do this in a flash of a second. So some of the things we have done is, I brought you a little video where we can very quickly analyze the results of hundreds of models, understand if this model behaves better with women than with men, understand if this behaves better with more than 45 years old or less than 45 years old, and then adjust our strategy based upon the feedback we are obtaining. But we don't wait 1 month to get this. We wait 1 day. We leave the machines training this during the night, and when we arrive the day after, this is already there for us to analyze the data. So this is just an example of what can be done to change the way we approach care using machine learning. Now, one of the things that I've learned through this process is that you really need to involve clinicians in this. If you work alone building this stuff, you will fail. And the other reason why you need to involve them is that if you just look at the data, there will be things in the data that you won't understand. You will take them as fundamental truths, and probably a physician that knows the process in the field will tell you that that is happening because he's giving some antibiotic or some other drug to the patient. And it's because of his intervention that you are seeing that data. So, I'm having some problem moving the slide. But just to summarize, okay, no problem. Just to summarize, and to finish this, I know that some of you, based on what I have talked here, might be skeptical. And I understand that. But for those people, I would like them to think that you are inside a bar with your father or with your grandfather, and that person over there suddenly has a pain in his heart. And you need to rush to the hospital after having seen this. And you have 2 roads. One road takes you to an hospital where this doesn't exist. And the other road takes you to this hospital. And I would like you to think, in that specific moment, what road would you choose? Thank you.
Jose, thank you very much. Appreciate that. Thank you.
Thank you.
I've been down that road, by the way. Scary
what
one.
What you choose?
Well, it wasn't so much about a choice. It was about provisions there when my mother fell and she had a heart attack. And that was about 6 years ago. And it's interesting when you think that, it's all well and good asking the question I would put to you. Respectfully, of course, but it's about having the framework in place within a hospital that enables you to make that choice, and many people don't have that choice. Questions from the floor to Jose, some really thought-provoking stuff there. Thank you so much. Gentleman over there, we're going to get a microphone to you there. Any other hands up this side, then wave them proudly. And to you at the back, I'll bring a microphone to you as well. Thank you. So just to you first. Hi.
Hi, I'm Harry van Goor from the Netherlands. I'm a surgeon. Very interesting talk. You are able to predict what's going on. How far are you to predict what we have to do?
You've got to pay him a lot of money to answer that question, actually, to be fair. But yeah.
We try not to interfere in that specific space. We show the problems, but I think it is very dangerous to suggest certain action. I think that is something that clinician needs to think about. We just concentrate in showing the problem.
But your prediction model is influenced by actions that were taken by clinicians. So anyway, in your prediction models, there are some action involved. So you can look if some actions have a better result than other actions. That's my question. And that's also what puzzles us in our institution, because we can predict also a lot of things, but we want to predict or to guide what we have to do that we know that has a better outcome than other things we do.
Yeah, that's a concern for us too, because when you learn from data, some interventions that clinicians do might bias those algorithms. And there's a specific case of pneumonia that I think everybody knows, that a patient with asthma that goes into the emergency room and has pneumonia is given lower risk by these algorithms. And why? Because clinicians were treating those patients better because they were high risk. But the algorithm didn't know that. So that's something that is a concern for us. If you look at the literature, there are a lot of brilliant guys working on this, and I think nobody has still figured out the right solution. Thank you.
Thank you. And to the gentleman at the back there, hi.
Thank you so much for the presentation. This is Mohammad Faraji. I'm a data scientist in Roche. I actually have two questions. The first one is, would you please share your experience for transition from the exploratory phase to the more operational phase, where the clinical decision support is actually used by the physicians? Because usually there is a lot of regulations which does not allow you to just simply use a model that has been built, and it has to be verified, and it's a very time-consuming process. Can you share experience? And this is actually first question. The second one is about the maintenance of the models that had been built. Using the new data, you basically have to regularly check whether you can come up with better models or not.
Okay, we're running out of time, but if I can just take one. Which one, the former or the latter?
The first one.
The first one, okay, thank you for that. And perhaps then you can have a conversation yourselves.
Sure, I'll be glad to do that. Regulation is not my expertise. We have departments that treat that. We try to move fast in parallel with that process. But what I can say to you is that these unsupervised models, they are not running every day for every patient yet, because we are looking after that process. But the supervised ones are, because, as I told in the beginning, we try to do a mix of AI and expert rules. And what we show to the clinicians is the mix of both, an explainable interface where they can understand what these models are doing. Because if you don't do this, and you just show them a black box, they won't use. Simple as that.
Thank you. Jose, thank you so much for being with us. Really appreciate your time. Thank you so much.